Hi dear audience, today I am going to discuss how to calculate the area of a circle inscribed in a triangle, scalene triangle. This was supposed to be a scalene triangle. It looks like as if it were a equilateral triangle, but it was supposed to be scalene. Anyway, the derivation applies even if it is a scalene triangle. Anyhow, let us now set out to calculate the area. Here we have the triangle ABC. Vertices ABC. The side opposite to the vertex C is of length C, and let's call it, and the side opposite to vertex B, that is AC, let us call it B, of length B, and the side opposite to the vertex A of length A, but this is the side BC. Anyway, and the circle of radius R, and R is OA, the length from the vertex O to the point of tangency to the side BC is equal to R, and the length from O to the point of tangency to the circle with side AB is equal to R also, and the distance between the vertex O to the point of tangency of the side AC or B with the circle is also equal to R. Well, now here the area of, let's start to calculate the area of the big triangle. Okay, will lead us to calculate the area of the circle. Anyhow, how? Let's start with triangle AOB, and thus the area of the big triangle formed from these three triangles ABO, AOC and BOC would be the sum of the three triangles AOC plus AOB plus COB, which is R times A plus B plus C over 2. And from trigonometry we have the area of any triangle in terms of its three sides, if they are known, is equal to the square root of, but from trigonometry the area of a triangle based on its side lengths is the square root of S into S minus A, S minus B, S minus C. As I said before, S is equal to A plus B plus C over 2. That is half the perimeter of the triangles. Half the perimeter minus one of the sides times half the perimeter times the other side into half the perimeter minus the third side, of course primarily multiplied by half the perimeter. Okay, now we'll solve for R by equating the area obtained by these two methods. Area equals R times half the perimeters. Area equal the square root of half the perimeters times these three brackets as I explained before. So as you see here, R square would be equal to S minus A, S minus B, S minus C over S. The S square cancelled with the S, and then transferring the S in the denominator of the left hand side, we get R square equals this fraction, and then R equal to the square root of S minus A, S minus B, S minus C over S. Now how does this hold a relation with the principle of units of dimensions? That the simpler thing in units and dimensions. Here we have S minus A, that's length, S minus B, that's length, S minus C, that's length. So we have the cube of length over S, which is length. This means we have the cube of length over length. This makes square of length under the square root that gives length. So this formula is primarily supposed to be correct. If it is dimensionally incorrect, then it is necessarily incorrect. But primarily it is correct. Of course we know it is correct. Okay, hope you enjoyed the ABC in units and dimensions. We'll get more into units and dimensions because it is the vertebral column of the spinal cord of physics actually. Okay, bye dear audience, thank you for watching.